So we've seen how to define methods using parameters and code and return values, but it's instructive to see how they actually execute. And what we're going to do is look at how input values are prepared and placed on top of a stack. Now a stack in computer science is the same thing you might imagine in a cafeteria, say where there's a stack of plates and the plate you take is on the top. You have no access to what's below, you can only remove the topmost plate. And so the called method's going to receive values using this stack, and we'll see examples of this shortly, and place the answer on the stack also as it returns. And this stack is useful for allowing one method to call another before the first method is actually finished. And we'll examine this in detail, and we'll use the Java debugger to see how that's going to work. So take a look at these two methods, add and multiply. They're already written out for us. And what I want to do is show how they actually execute. And what we're going to do is first assign x and y, the values of 5 and 2, respectively. Then we have a nested call. We're going to call add, passing it 1. But then its second parameter isn't a constant. It's the result of calling multiply on x and y. So in order for this to work, the add method is going to try to begin executing first. Its first parameter is a 1. And so the 1 is going to be placed on the stack first. And here we see the 1 sitting on the stack. Anything below the stack is irrelevant at this point. There may have been other methods that executed prior to getting here. So we're just looking at the point where the 1 is placed and above on the stack. Now in order to call multiply, we have to push its parameters on the stack. And x and y get the values 5 and 2. And they're shown pushed here on the stack. It may look backwards, but remember the first parameter gets pushed first, and that's x's value. So the 5 gets pushed onto the stack first, and then the 2 gets pushed second, leaving it on top. So with 5 and 2 pushed on the stack, multiply is ready to begin its execution. It starts execution by popping those values off of the stack and receiving them as the values of its local parameters c and d, as shown here. Now once c and d get their value, it's just like we've seen before, they can be mathematically substituted wherever we see them. So we start to execute the multiply method. We set sum equal to 0. We enter our for loop where I starts out initialized at 0. And then we have a statement sum is equal to the add of sum and c. Now the minute we hit the add of sum and c, that's another method call. Our stack is where we're going to place the inputs to the add method. In this case, the value of sum, which is 0, and the value of c, which is 5, are placed onto the stack in that order, so the 5 for c is on top. The multiply method suspends execution at this point, waiting for add to return its result. So we have to look and see what add does. Add takes two parameters, so it pops them off the stack, receiving them as a and b, respectively. These are then added together, and the result, when we're done, is pushed onto the stack. So after add is finished, 0 and 5 were popped off the stack, and the result of their sum, which is also a 5, is pushed on the stack. Multiply gets to pick up execution again once add is finished, and it knows to receive the answer from add from the top of the stack. So it pops it off the stack, substitutes it for the call to add, and then sum can be assigned the value 5. We come around the loop, and I gets incremented to 1, and we're going to do sum is add of sum and c again. This time, the values of sum and c have changed slightly. C is the same, but sum's value is now 5. We're halfway through adding 5 twice to get 10. So in order to call add, the two 5s are pushed onto the stack, one for sum first, one for c second. Add is then called, pops those off the stack, receives them as a and b, computes their sum as a plus b, and that value gets pushed onto the stack as the result of add. Multiply picks up execution again, receiving its answer from add from the top of the stack. That gets substituted for sum. Sum is now assigned 10, and I being incremented to the value of 2 causes the for loop to vacate, and we're at the return statement. So now multiply is ready to announce its result, and it does so by pushing the 10 onto the stack. Now we're back to the very first call of add, where we pushed 1 on the stack and then waited for multiply to finish its result. That result is finished and has been pushed onto the stack. So add has 1 and 10 on top of the stack. It receives those as parameters a and b, computes their sum as 11, and then pushes that value onto the stack. And if there was something that called add above this, that would be received after that by pulling the 11 from the stack. So in this way, we see how methods are receiving their information from the stack, from the top, pushing the results on top of the stack, and this allows the methods to interact with each other effectively.